Welcome to solverfy.
We know that when we look at temperature and pressure and the relationship between them for a gas, that they have a direct relationship, which means that if I increase the temperature of a gas, I'm also going to increase the pressure that is exerted by that gas. And the question is, how can we use kinetic molecular theory to explain this relationship that we can observe? And so one of the tenets of kinetic molecular theory is that the average kinetic energy, which I'll abbreviate as Ke, is directly proportional to the temperature of a sample of gas in Kelvin. So the average kinetic energy of a sample is directly proportional to the Kelvin temperature of that gas. So why is that important for us? Let's say we have a container, and in that container we have a gas. And of course we're filling up the entire space with that gas. And then I'm going to add some heat. So when I warm up my sample of gas, what's going to happen is that if I'm increasing the temperature, if temperature is directly proportional to the average kinetic energy, that means now my gas particles have more energy and they're more likely to collide with the walls of the container. And they're also going to hit the walls with much greater force. So I give them more energy, they hit more frequently, and they have more force when they hit. Now, how does this relate to pressure? Remember that the pressure of a gas is caused by the collisions of the gas particles with the walls of its container. So let's go through this logic. If I increase the temperature on a gas and I warm it up, that means I'm increasing the average kinetic energy of my sample of gas, which leads to an increase in the collisions of the gas particles, as well as an increase in the force with which they collide, which we will register then as an increase in the pressure that is exerted by that gas.